Hello, so let's start with A-level physics, dynamics past applications. Our first question is that two blocks x and y of masses m and 3m respectively are accelerated along the smooth horizontal surface by a force F applied to block x as shown. What is the magnitude of the force exerted by block x on block y during the acceleration? Our first step would be to find the acceleration A, which would be F equals the total mass, which is of x and y, m plus 3m. A, we will make A the subject, which would be F over 4m. Now the question says, what is the magnitude of the force x exerted by block x on block y? So we need to consider the mass y, because force is being applied on y. So the mass of y is 3m, and acceleration F is equals to ma. The acceleration is being the same because both experience the same acceleration. So the acceleration would be F over 4m. So multiplying these both will give you 3f by 4. So D is the appropriate answer. So our next question says, a body initially at rest explodes into two masses m1 and m2 that moves apart with speed v1 and v2. Initially, what is the ratio v1 over v2? So it says initially the body was at rest, so we can say that the initial momentum is 0. The momentum after collision is the bodies will move in opposite direction because it says they move apart. So v1 m1 and m2 v2. We taking right hand side as positive and left hand side as negative. The equation for momentum after collision would be m2 v2 minus m1 v1. So applying the conservation of momentum, the summation of initial momentum equals summation of final momentum becomes 0 equals m2 v2 minus m1 v1, and making v1 over v2 the subject gives us m2 over m1. So our final answer is B. v1 over v2 equals m2 over m1. So our next question says that the graph shows a variation with time t of the momentum of a ball as it is kicked in a straight line, and it says initially the momentum is p1 at time t1, at time t2 the momentum is p2. What is the magnitude of the average force acting on the ball? So over here what we can do is we can consider rate of change of momentum as final momentum minus initial momentum over change in time. So our change in momentum is p2 minus p1, and change in time is t2 minus t1. It says what is the magnitude of the force acting on the ball. So we have to apply Newton's third law, which says that the force AB equals minus force on BA. So according to Newton's third law, this is the force which the ball exerts. So the force acting on the ball would be P1 minus P2. So our final answer would be B. So our next question is, a tennis ball of mass 100 gram is struck by a tennis racket. The velocity of the ball is changed as shown. What is the magnitude of the change in momentum of the ball? We have to find the change in momentum, which is basically mv minus mu. Our final velocity is negative 30 and our initial velocity is positive 20, and our mass which we require is 100 gram, which can be converted into kg. So this would be 0.1 kg. Just plug in the values and get negative 5 kg meters per second. The negative sign shows that the resultant momentum is towards left. So B, 5 kg meters per second is the appropriate answer. Thanks for watching my video, and do like and subscribe my channel for more videos. Thank you.